All right, so these notes are going to be on conditional statements. This lesson is going to feel like an English class or language arts class. So if you like English, good, right? You're probably going to like this lesson. If not, just know it's going to be different. And I still think math people like it too, because it's still the same kind of logical mindset. But here we go. So go ahead and this is review. So go ahead and try these warm-up problems, pause the video, and then we're going to get into that lesson. All right, so you should have completed it. So since this is on a straight line, we're going to set it equal to 180. All right, we'll combine like terms. Subtract 56 on either side, and we get 124. So x is equal to 31. All right, this box right here is telling me this is 90 degrees, so I can do 2x plus 2 plus 64 is equal to 90. I'll combine like terms. Subtract 66 on both sides, so 2x is equal to 24. So x is equal to 12. All right, same thing over here. We have a 90-degree angle, so we'll set it equal to 90 degrees. Subtract 27. 3x is equal to 21, or 63, sorry. So x is equal to 21. Over here, we know this whole thing is equal to 360. So we do 360 minus 296, and that's 64. So then we know this part is 64. So we add these two, we add x minus 66 plus 32 is equal to 64. Combine like terms. Add 30, 40 both sides. So we get x is equal to 98. Okay. All right, so let's keep going. So what we're going to talk about first is this vocab word called conditional statement. So a conditional statement, it starts with if, and then it's also called an if-then statement. It doesn't always have to use the word if and then, but for the most part, you will see it like that. So it's a logical statement, has two parts, a hypothesis and a conclusion. Okay, so in words, it would say if P, which is a hypothesis, then Q. Okay, and in symbol form, we'd write it like this. Where P is the hypothesis, Q is the conclusion. So let's look at this example. All birds have feathers. Okay, so if we want to write this in words, all right, we'd say if it's a bird, then, whoops, sorry, I didn't mean to put a comma there. It has feathers. All right. So if it's a bird, then it has feathers. So what we do for, this is another vocab word, we take our conditional statement and create a converse. So it switches it. So in symbol form, we'd write it, instead of P then Q, it'd be Q then P. Okay, that's what the converse means. So we need, in order to write this, we'd say if it has feathers, then it's a bird. Okay? Sorry, that's not a straight line. Then the inverse, okay, is negating both the hypothesis and the conclusion. So negate means to take the opposite, so opposite. Kind of make note that it's opposite. All right, so we'd say, this is another word of saying this is not Q, or not P, then not Q. So we leave it the same, right? This one up here is P, then Q. So we keep it the same, but we just put a little not symbol in front. Okay, and you'd say if it is not a bird, then it does not have feathers. If it is not a bird, then it does not have feathers. So we basically just took the original statement and put a not in both places. All right, so contrapositive is switching and negating both, okay? So the way we write this is not Q, then not P. All right, so we take this and we go, if it is not, if it does not, let me start over, okay. If it does not have feathers, then it is not a bird. Okay? And when you're doing these, they don't always have to be true. Okay, so if you're going through here and you're saying, oh my gosh, that does not make any sense, okay, mostly this is just a pattern, okay? So for converse, this by the converse of a statement, you just switch them. Inverse is negating or taking the opposite of both. Contrapositive is doing both the converse and the inverse, okay? Switching them and negating them. All right, so this is a vocab word that you're going to need to know, a biconditional statement. And this is what we're getting into up here, right? When I said they're not always going to be the same, that's what sets a biconditional statement apart, okay? It's when a statement and its converse are both true. So you can switch them and it still be true. Then you can write it as a single biconditional statement, okay? So in words, it says if P, if and only if Q. Okay, so if you see those words, you may have seen them before in some kind of theorems or whatever, okay? But if you see those words, that means biconditional. All right. Then these are the symbols that represent that. Okay, so here's an example of a biconditional statement. If two lines intersect to form a right angle, then they are perpendicular lines. Okay, so the converse would say, okay, if the lines are perpendicular, then they intersect to form a right angle. Okay, then I'm writing this as a biconditional statement saying two lines intersect at a right angle if and only if they are perpendicular lines. Okay, so that's biconditional. You're going to need to know this definition for the test, right? As well as a lot of these, okay? So, what I want y'all to do is I'm going to do this first one, and then I want you guys to try the rest. Okay.